Well, hello everyone. I guess we're online and we're getting started with our session number 2 for the Oregon Forage and Grasslands Council Forage e-forum. This is our weekly uh, online sessions of with information and guests, and we're glad that you are attending. I'm starting a little bit slower because it takes a little time for people to come online. But what we're doing here is I want to welcome everybody, and we're really happy that you are joining us. I'm Woody Lane. I'll be the host facilitator for today, and I am the forage. Those of you who don't know me, I'm a forage and nutrition specialist, and also the president of the Oregon Forage and Grasslands Council. Our guest today is Tom Maxwell, and he's joining us from Lincoln in the South Island in New Zealand, and he has a PhD and is a lecturer of pasture science at Lincoln University. And just for everyone's knowledge, it's 7 o'clock in the morning there. And Tom has been gracious enough to be up early enough to do that. We'll get started with that in a moment, but just letting you know what we're doing here is it's going to be a back and forth discussion. Tom's got a lot to offer, and we'll be going back and forth in a conversation. They'll be showing stuff, but also you'll be able to ask questions to us. And if you look at your screen, look at the bottom of the screen, you'll see something called Q&A and a chat. Those are two different formats. But if you want to ask questions, I suggest you use the Q&A button. You just click on the button and type in your question, and we will see it, and then we can go from there. So, by all means, don't be shy and ask some questions, and that'll help guide the conversation. So that's what we will do. We'll get started. And Tom, we're certainly glad that you have joined us, and it is 7 o'clock in the morning, and that's very gracious. And on the other hand, it's already tomorrow, so you can tell us what already happened today here. But thank you for coming online, and it's good to see you again.
Thank you, Woody. Appreciate it. It's really great to be here with you, and thank you for the invitation to join your e-forum meeting. Really looking forward to
it. Could you, we'll start for a short period, just tell who you are and what you're doing, and keep, a minute or so, and then we can go on from there.
Sure, yeah. So those have just joined, my name's Tom Maxwell, dialing in or zooming in, as it were, from South Island of New Zealand. I'm a lecturer in pasture science at Lincoln University, which is one of the two only agricultural focused universities in New Zealand. My area of interest is the function of grazing lands. So I'm trained as a pasture ecologist, but that means I've delved into soil, animals and plants, and I do research and teaching here at Lincoln in that space of pasture ecology, where we find particular species of grass, legume, herb, forage, resident species in hill country, lowland, flats, dairy pastures, and more extensive rangeland type areas. And looking at how we fit the species to the environment for the function of grazing livestock animals. I'm going to be sharing, I guess, Woody, as we talk along, about some of the research and some of the trends and developments that are going on in New Zealand, or the challenges and problems that we're facing in pastoralism in New Zealand, which brings in not just biological aspects of this agro-ecosystem, but socio-cultural and economic forces. I've decided to go down an academic route, but very applied in my thinking and aspirations in this space.
So Tom, Lincoln University is located right there on the Canterbury Plains, and which is one of the richest in agricultural sections anywhere. Over the last 20 years, a lot of changes have occurred. They've gone from sheep to heavy dairy cattle, grazing dairy cattle, and much more intensive use of forages. How is that changing everything relative to the environmental uh, some of the questions that you have to face in terms of agriculture right now.
Yeah, that's highly topical, Woody. Just a 30-second history. Yeah, the Canterbury Plains is basically an alluvial floodplain. It's rock dust that's come down from the Southern Alps, the main mountain chain west of here. And traditionally it was a mixed farming system with some cereal cropping, mixed sheep with peas and oats and things like that. But in the last 15 years, the advent of improved irrigation systems has meant there's been greater intensive irrigated pastures for fattening lambs and then dairying. Now, that has had an impact on the fresh water quality in certain areas to do with runoff of high nutrient, particularly nitrate, into areas. And there's been a pushback through society in environmental policy about improving our freshwater quality in terms of underground aquifers and freshwater streams that are located nearby or downstream in the watershed from intensive dairying areas. Dairying, unfortunately, has been in the spotlight. It's an easy target because of the number of animals that you can get on a given acreage or hectareage, as we do in New Zealand. But it certainly has influenced practice on farm around how much nitrogen you are allowed to apply to your dairy platform, so the area that you graze your cows. And
that really indicates that there are rules that farmers have to follow in terms of how much nitrogen or how much whatever. They can't just add whenever they want. Or how much they want. There are some regulations about that, aren't there?
Yes, there are. So for an annual period, generally, it's actually just changed last week. So generally, I'm going to have to, I'll state it in kilograms of nitrogen per hectare, Woody, and perhaps you could do a quick transfer into...
it's easy, it's 1 to 1. It's pounds per acre. We teach it that way. Kilograms
per acre,
and everyone's
so
figure it out.
Okay, I'll go with that. On the Canterbury Plains or the Canterbury region, I'll stick with that, and there's some variation throughout New Zealand, but the Waikato and Canterbury are dairy dominant areas, and 250 kilograms or 250 units of N for a farm, but that's generally staggered over the growing season, usually applied after a grazing event. But in terms of cumulative amount of nitrogen, it's 250. That has changed as of last week to 190 units. This is nationwide.
That's 190 units of nitrogen per acre. Units per
that
acre.
Can be applied to a farm area, whether that's the dairy farm area, which the average size in New Zealand is 460 cows and, between 150, 190 hectares on average as a functional economic unit.
So 190 units of nitrogen, that's per acre.
Yeah.
Or is that per hectare?
That's per hectare.
So it's 190 units. That's that's a little different, because a unit of we call a unit of nitrogen as a pound, but you probably have a unit of nitrogen as a kilogram.
Yes.
Well, I'm sorry, that'd still be the same, nonetheless.
That's why I said units, because it would.
It
doesn't matter the land area. Yeah. So as a result, that will have an impact on production outputs, but that will have benefits as well with regards reducing costs of urea fertilizer, both economically and environmental footprint impacts. But with regards to practice, so that's influenced practice. Farmers are very aware of the nitrate issue. They need it because of the way the pasture system has evolved in the last 10 to 15 years, which is geared towards greater production for milk solids, for export, or milk powder for export. And generally, the now ryegrass dominant swards, the white clover component, the legume nitrogen fixing component has dropped because the grass has responded more quickly to the freely available nitrogen and shading out the clover, which has meant, yes, we have high yields and greater utilization in some cases, but it's more the quality in some cases of that production has dropped, that the quantity has come up. In terms of pure biomass yield per acre.
Tom,
Yeah.
if the amount of nitrogen per hectare or per acre has been limited to 190 units of nitrogen per acre, and for those who are doing a lot of, obviously there must have been people adding more, otherwise it wouldn't have been a concern. But if they have to drop back, wouldn't that suggest they would want to increase the clover component of their swards? And you're saying that they're actually dropping it, and that kind of goes against the loss of nitrogen all the way around.
Yeah, it's that's a good question, Woody. So the legume component in the sward has reduced because of greater urea nitrogen application favouring the grass. Now, yes, with this advent of, okay, the cap is even lower now, we can't, the amount of nitrogen you can apply is reduced even more. Those farmers that are aware or appreciate the value of legumes to their system biologically and thus economically, yeah, it's good news for those of us that are legume biased, as it were, but for good reason. You work with the environment more than against it. It could increase the diversity of the pasture community on an average dairy farm, because it's, as we say in New Zealand, it's a saying, money for jam, easy or value for jam with more clover content. So kind of going back to the past, where you were aiming for 20-30% legume component in a dairy sward, or even more. Just have to manage grazing times and when the cows come off, because of course sheep and cattle will absolutely deck a legume dominant pasture over grass. So yeah, I think it's gonna require a bit more fine tuning, or having the grazing management aspects, thumb on the pulse, very much more in tune with their pasture, perhaps. But it's not just grass and legumes that have emerged in response to trying to reduce the environmental footprint of dairy farms. And what I'm alluding to there is an advent of herbs or forages, specific forage species for reducing nitrate leaching. Catch crops like oats, Italian ryegrass being strategically planted to take up more nitrogen during the cool season, when it's more likely to leach through the soil profile and thus get into groundwater. So the idea that the tactic or the mechanism, the strategy there on the ground, is to have species that are more hungry for the nitrate or the nitrogen in the soil when the soil temperature is down.
Which one?
Italian ryegrass particularly, but also in the rotation of pasture renovation, things like oats following a winter brassica crop, literally as a catch crop, catching that nitrogen, and that silage can be made from that crop of oats before that particular land area is then put back into a more permanent pasture again.
Use some herbs like chicory and plantain. I mean, I saw it in some pictures of yours earlier, but those would be typical things, because we use them here, and I imagine they use there for the same reason.
Yes, plantain particularly across the country has been given some good press based on research coming out of the likes of here at Lincoln and Dairy NZ, Ag Research, Massey University, essentially showing how it could be used in a dairy system, not just dairy as well, sheep and beef or mixed cropping. But the value of plantain, which is has multiple functions. My partner, who's actually from Washington State, Seattle, she did her PhD here at Lincoln on plantain, looking at the effect on cow urine, and when the urine hits the urine patch, what effect does the secondary plant compounds in plantain have on nitrous oxide emissions, a potent greenhouse gas. That's one of the other kind of targets for environmental footprint criticisms of intensive grazing, particularly dairying as well.
Not everyone probably is right on top of that particular question, but you're saying something that they've increased the number of cows, if you will, per hectare, per acre. They urinate. There's a whole lot of nitrogen hitting the ground, and what you're saying is that what the research is showing, and you're involved in this research, I know, is that a plant like plantain with the secondary compounds is affecting the nitrogen flow from the animals into the ground in some way that would reduce the amount potentially reduce the amount of nitrogen going past the root zone into the groundwater.
On a Zoom.
So touch about that a little bit.
I'll call you, Ant.
There's something else coming through the microphones here somewhere.
Did John have a question, or?
No, go ahead.
Okay, yeah, no, that's right, Woody. Essentially, there are chemicals produced, or we call secondary plant compounds, but bioactives being produced by the plantain herb, which slow down the transformation of one species of nitrogen into another, from a species that is more bound up in the soil, ammonium, which is positively charged, so it's held onto a soil clay colloid which is negatively charged, to nitrate, which is negatively charged, and so they repel. It's more likely to leach. And essentially, there's evidence showing that things like occubin and occubiginin, there's a whole host of others that are these secondary plant compounds, can slow down this nitrification process, the mineralization of urea to ammonium, that's what we call to nitrate. The other side of it is that it's a natural diuretic, like coffee or beer or too much tea makes a mammal urinate more. However, the concentration of that urea nitrogen in the urine is reduced. There's been numerous studies through Lincoln particularly showing that plantain has an effect on reducing, not in every case, but can have an effect in reducing urinary nitrogen concentration. So two things there. We've reduced the nitrogen concentration and the cows are urinating more, or the sheep are urinating more. Now they're going deeper into it. They're thinking, well, it's the mechanism that actually by urinating more, you're spreading the same amount of urine, but it's not all on one patch. It's being dissipated over a larger area, which is still a benefit. And or each time a cow or sheep urinates, the amount of nitrogen is less. Now the other side is, well, where's it going? Because in terms of a nitrogen balance in the animal, the ruminant, some studies have shown, well, it hasn't changed in the milk. It hasn't changed in the feces. Is it being retained by the body more in muscle, live weight, things like this? They're also looking at, well, what happens when in the rumen itself do these bioactives that we are interested in get broken down, or do they survive the rumen and are still active once they hit the urine patch? That's where the research was most recently. Now, chicory is interesting as well because it's more like the summertime. Deep taproot can give really good biomass yields over the summer as a sort of specialist feeding crop in dairy pastures particularly, and also for sheep. And that's also had an effect on, has shown to can reduce urinary excretions. So those are the two herbs, going back to the big picture, that are also available now commercially for intensive pasture grazing pastoralists.
We use them
A
here.
lot of-
There are many people in Western Oregon that use, I mean, chicory and plantain, various varieties, are routinely used in many, many pastures. I don't think we've actually looked at the nitrogen, that aspect of it. It does suggest that there ought to be lots of trials, perhaps very serious trials comparing plantain and beer, for example, as a diuretic. That would be really interesting ones to cover. Never mind, keep going.
Yeah, well, you know, so far I've been sort of talking about specific species, and the image in your head might be, okay, so we've got a field of chicory, we've got a whole field of plantain, but a space that I'm working in closely and that's closer to my heart is like pasture diversity. Numerous species in a community that of grassland or pasture that we use to graze our animals, and what combination is the best? Do we have more of plantain, less of red clover, more of Italian ryegrass, perennial ryegrass? Do we have a little bit of alfalfa or orchard grass in there? Why? You know, so one study that we're doing with sheep is showing that, perhaps to show some photos before the hour's up, but is a combination of Italian ryegrass, red clover, and plantain compared to a good old standard perennial ryegrass and white clover. And what we found there, and this is to fatten lambs, but also to rear them on. The pregnant ewes give birth onto these different pastures, and they rear, they're lactating, so they're grazing this forage as well as providing milk for the young, and so on. But what we found is that there's greater live weight gain on that diverse pasture of your Italian red clover and plantain. And per kilogram of live weight gain achieved or seen by an animal, for every kilogram of extra weight, body mass, the excretion of urinary nitrogen from that animal has dropped.
Oh, that's an interesting thing.
Yeah, so I'll just say that again in case it's a bit long-winded, but so for every kilogram of live weight gained, the grams of nitrogen in the urine of that animal is less.
Which suggests more has been retained.
Yes, it does, Woody. Yeah, and we're not sure. We're wanting to delve into this more. Is that purely a plantain effect, or is something like good old red clover having a positive effect as well through its secondary plant compounds, which there are some.
You have a
And
picture.
also the Italian ryegrass with greater water-soluble, greater digestibility, water-soluble carbohydrates for certain times of the year.
You have a picture or two of one of those pastures, don't you?
Yeah, should I share that?
This would be good.
Now?
Right now we're talking about those pastures. We're going to switch topics right after that. So this is a good time. People can look at their screen. Tom is sharing his screen, and we hope the technology works. And these are some of the fields that are not far from Lincoln.
Yeah, so let's go to that.
Especially the ones that have multiple different species and things that you're doing on. Show 3 or 4 of those. Would be really
I'll minimize that.
Yeah.
Is that all right, Woody?
I can see it. Everyone else, can you see it? Raise your hand. Okay.
Yeah, so this is just down the road from Lincoln University. You can just make out the, that comes down, the Port Hills there. Christchurch is not far away. So this is the first year of our Italian ryegrass, plantain, red clover mixer. This photograph was taken looking into the sun. This next photograph I'm going to show you is the other way around. So here you can see several things, those with sharp eye. We've got some darker green areas and lighter green areas. Of course, those dark green areas are urine patches, but that is after a first grazing and then topping to get us back to uniform. This was the first time it was grazed. We let it go a bit long. It was about a foot long before we grazed it, a research experiment farm. Just as a side note, as big fire in late summer a couple of years ago on the Port Hills, simply because there wasn't enough grazing going on old, what we call tag standing dead matter like this. It's
Is that a wildfire or is that an actual controlled burn?
no, that was a mistake. It's either a glass bottle in an awkward position magnifying the sunlight, or somebody's cigarette butt, or a spark from a tire going fast on a road up in the hills there. But it caused a lot of damage. But just another reminder of the value of grazing it in the right place at the right time, reducing the fuel load of potential wildfire risk. But back to this irrigated pasture. So there's our diverse pasture again. This is, we've probably got infrastructure like this in the Willamette Valley, other parts of Oregon.
Well, this is kind of funny because you've got that equipment for irrigation, and yet Lincoln University is just a couple of miles from where K-line was developed.
Yeah, that's right. Center pivots are kind of if you can afford it, the much more common now. You still see a rotorainer every now and then, and K-lines in some situations where the border with a center pivot cannot reach. But there's a bit more of a close-up of the clear rosette and the plantain-like finger-like leaves there.
What time of year was that? Go back to that one. What time of year?
Oh, this was late spring.
Late spring.
Yeah.
Why is there open ground like that? There's open ground there.
Yeah, so that's a very good question, Woody. You've got a sharp eye. Now, there's two factors going on there, and this may lead to more questions or of inquiry. Is selective grazing or grazing preference has been expressed there, in that the sheep went for Italian ryegrass and red clover first, and plantain was their last preference.
Really? Plantain was the last preference.
If we were to let the animals in, I've got some, let me just show you another photo that is conducive. Here we go. Right, so we've let the ewes in there. You can see the height of the pasture, quite lush. We've got the light green leaves intercepting that afternoon sunlight there. We've got the darker green Italian ryegrass leaves, and there's red clover in there as well. The ewes came off, and that's what we got. Now, there's quite a bit of trampling of the plantain leaves, but the preference was Italian and red clover, or red clover Italian first. So the plantain, I've observed many times, is left for the first, often almost a week, if we're leaving these lambs in there for 10 days to 2 weeks. Mainly because they haven't been exposed to it. There's anecdotal evidence or comments coming from the farms of, oh, yeah, okay, you've shown us that plantain has these environmental benefits, but the stock don't like it. Slang terms like, oh, it's a dog of a plant. Why would you plant it? They don't want to eat it. Now, others say, oh, no, it's been great. My animals really like it. It's what's an animal has been exposed to in its life, its nutritional wisdom or its nutritional history. Plantain, if you ever tried it yourself, is bitter, a bit astringent, a bit like arugula, a rocket kind of flavour. And that novelty, or it can come across as like neophobia. If the animals can, I don't know what this is, don't like it. As over time, we've seen the utilisation increase and the rejection lower. In some cases, no longer. They've actually then targeted the plantain after a while. So, interesting dynamics based on the animal's grazing preference or its nutritional diversity it's had earlier in life.
Well, by just increasing the stocking density enough, that can take away the luxury of having to choose. And by changing the grazing management, you can very much change the way the animals intake forages. So increasing the stocking density, their preferences kind of disappear when they have to kind of eat in a hurry.
Yeah, it's interesting you mentioned that, Woody, because that's the sort of approach the dairy farmers have taken as using a pure standard plantain in the summer or going into the autumn, is trying to up the stocking density to kind of erase that preference factor a bit. But sure. Yeah, what do you want to move on to?
Let's change this topic a little bit,
Yeah.
perhaps.
Okay.
We
Shall I
can-
stop sharing the screen for now, or leave it on
might
there?
just leave the screen on because at this point people are looking at the pictures, even if they're kind of interesting pictures for a lot of folks who may not have seen them, anything like this. Change a little thing about in the area. Have people gone more to no-till type of approaches towards pasture management, or are they still doing a lot of tillage, disc stuff like that? And if there's any no-till, has there been any studies about long-term effects of it, environmental effects of it versus the more traditional tillage?
Yeah, the general trend has gone to direct drill, so spray and then direct drill, so minimal tillage if done at all. Where we do tillage is a light rotivation, or just a light disturbance to the soil profile, to the soil surface, which I have actually a picture of here. Bear with me a moment. I was showing you guys earlier. There we go. Where was it? There we go. So, with regards to pasture and bringing in new species, or a improved species, or a new legume or a new herb to that environment, often it's direct drill or overseeding, either broadcasting from the drill or from a plane onto more hill country areas. But any cultivation that's done these days is like this. So it's rotivation, light surface cultivation, and then direct drilling into that. So what you're looking at there is an old, slightly run down perennial pasture that's just been sprayed out with a broad spectrum herbicide, and we've gone through with a rotivator, and we've established from that to that. Now, digging into that deeper, if you excuse the pun, is in the pasture rotation options for farmers. Before, say, from this situation to there'll be an intermediate phase where we have a forage brassica or fodder beet crop. Now, I have a photo here.
In a different, in between.
In between, so you have, in this case, it's this is winter. This is feed grown in the summer for feeding out in the winter.
What time of year is this?
This is late summer. Okay, so that bare soil there is with the wheel track for the centre pivot. But what you're looking at there is fodder beet, wilted a bit in the summer sun, but that's used either fed in paddock or lifted and taken to a platform to be fed to the cows. And then either Italian ryegrass will go into that area of land before a more permanent pasture mix of perennial ryegrass, white clover, red clover, plantain, in this particular dairy grazing situation on one of the university farms. Instead of fodder beet, people do kale or Swedes or turnips.
Swedes, by the way, is rutabaga. For those who
Rutabaga,
that
yes.
term.
Rutabaga, yeah, and
Brassicas.
generally, yeah, and used as strip fed over the winter time, and depending on where you are in the country, north to south, it would change from far south Swedes who were more moisture, deeper, wetter soil, to turnips or to leafy turnips, where actually the bulb, we've planted a cultivar with very minimal bulb, and it puts more of its energy into actually putting up leaves, so we have multiple grazings rather than just one graze.
We use some of those here too. Very much of the improved hybrid brassicas are very popular.
Yeah, pasture, things like that. I was talking to. So,
if we could switch a little bit, do you have there any very high organic matter soils? Because in Western Oregon, there are a number of, typically a lot of our soils are above 4% organic matter, which in our Midwest would be, they would love to have it. We have it very typically in the Willamette Valley, but there are some that are much higher than that, above 10%. Do you have soils that are like that? And if so, they're different in the way the recommendations are for being able to raise pastures.
Well, in the same way that where you get more moisture and apparent material that matches or that allows natural buildup of soil organic matter through something like more extensive grazing, yeah, we do have some high organic soils, but the country is quite diverse in terms of soil type because of parent material and climate. For instance, this photograph here, so this is the lower North Island, and easily prone to soil erosion actually in some areas because of high rainfall and grazing practices in some cases that haven't allowed great resilience of the pastures forward there. What you're looking at there is a red clover finishing crop, which actually is very good for renovating the soil in some cases. What you're looking at here is another part of the country. This is actually earthquake damage, but you can see how light coloured this. So this is midwinter. So this is a loess parent material source, so windblown silt. Now the organic matter there is the level is constrained by summer dry. Summer dry situations, so basically from late spring to early autumn, there's soil moisture deficit. So obviously the amount of growth and biomass above ground is restricted, and thus also the organic matter inputs underground. So it's very variable to answer your question, Woody. Apart from areas where we have some localized peat, I don't think we are reaching the same organic matter levels that you've quoted in some parts of Western Oregon. Did you say is something like 20%?
We have 15 to 20% right along the coast. Yeah.
But in general, the soil organic matter levels under pasture systems in New Zealand are stagnant or dipping slightly. In some cases they've increased, but there's a study done which looked at changes in soil organic matter under pasture over the last 27 years out of Landcare Research, which is a government research institute, and they basically looked at the top 30 centimetres of soil and the change in carbon per hectare per year in that soil, and it varied from a reduction of 0.7 tonnes of carbon per hectare per year for some dairy sites to a slight increase of a similar magnitude for sheep and beef farms. So it's going both ways, but
okay.
Yeah, it's very variable. But that is the other fact I just want to mention quickly here is that there's a biophysical limit to how much organic matter can be stored in hill country grassland soils in New Zealand. In some cases we can farm to a way that we want to increase it again, but it'll sort of reach a maximum point. Unless we do a complete ecosystem overhaul where we change the depth of the roots and favour species that are actually putting organic matter down, not down into the subsoil rather than increasing organic matter up towards the soil surface.
Which forages would do that? Would that be the forages with tap roots?
Yes, and also allowing things like shrubs to get back in, but they not generally graze. So, but yes, deeper rooted, longer lived forages like red clover, plantain to a lesser extent. Chicory is short lived but has that effect. Or having a diversity with multiple grass species and legume species that exploit different layers within that top sort of 7.5 centimetre, 15 centimetre level.
So is that the reason? That's the reason that you planted so much gorse?
Well, that's I don't know if we want to go there, Woody, but that was probably much more of to be fair, at the time it was a cultural historical thing, making things feel more like home for Scottish settlers and particularly Otago, but also as a pretty practical fence. keeping stock in
Oh,
and
yeah, it does that.
providing windbreak and shelter. And let's not forget that gorse is a very good nitrogen fixer
Oh,
as well.
fair enough.
But
Okay.
anyway,
Well,
I'm not advocating we should put gorse back in, but I'm just saying that it's not all that evil if you look at it.
We have a good question from Marty Cheney up in Washington. Asked, with the very light tillage that's going on, you showed some pictures there, just basically scraping the surface. How do you deal, or how do farmers deal with compaction that would occur over time with equipment in the past? How are they going to correct that if in fact they barely scratch the surface of the soil? Or don't they? They don't worry about it, and they try to do it, or through roots instead.
Yeah, you sort of practically answered that one, Woody. So generally, that we follow. I mean, imagine this be similar or the same in Oregon and Washington. Follow best management practice with regards to using heavy machinery and cultivating land. What you're looking at here is a hill country, but there's a bit of a plateau where they could get a tractor, and essentially they've established a monoculture of red clover for fattening lambs, and that'll stay like that for 3 years or so before they put it back into a more permanent pasture. But to avoid soil compaction, as the question was, is best management practice and lighter machinery. But where they do get it, it slowly fixes itself over time because of inputs from the animals, the deeper rooting, forages, and natural soil processes, turning over of organic matter from the grazed pasture, and also soil moving and sorting itself out through rainfall events and things like that. But just to make a point as well, is that the frequency of cultivation is few and far between if you look at it from a big picture role. So this area here has been used as a specific purpose, pasture, using red clover to fatten lambs in the summer, but that'll go back into permanent pasture for 7 to 10 years of a grass legume mix again, and wouldn't see a cultivation for that time, if any. Or in fact, this case here, from memory now, all they did was spray and direct drill. So they sprayed out. They didn't have a intermediary phase. They just sprayed and then direct drilled red clover. But that's one scenario. The other scenario is spray and then set up a leafy turnip or pasture crop before putting in a red clover and maybe a grass like prairie grass or orchard grass in there. So in terms of how often machinery is used to cultivate land is quite intermittent, and it's not a continuous thing on the same patch of land. This might not see heavy machinery again for a decade or more. Depends on the individual farmer and what their goals are. But following best management practice, putting in a brassica crop or a fodder beet crop is in itself having a cultivatory effect, or a breaking up the soil effect. But yeah.
So by the way, where is this picture taken? This
picture is taken not far from Masterton in the lower North Island. So Masterton is north of Wellington, our capital, and this is what we call lower North Island hill country. So it's just to the east. It's closer to the Pacific Ocean than the Tasman Sea.
Okay.
So, yeah, and the annual rainfall is about 800 to 900 millimeters.
30 inches.
Yeah.
Okay. Well, one thing that has come up, and I know a lot of people are interested in this, and I know you have done some work on this too. The legumes, there's standard ones that we always use, but what are some other ones that people are using there, or that you've looked at and said, this is kind of interesting?
Mm.
aside from gorse.
Thank you for that question, Woody. Yeah, well, subclover, I'm sure there's a few people listening who've heard of something called subterranean clover.
We grow it here quite a bit, especially in Douglas.
Yeah, I know Dr. Serkan Atesh is listening in here, and he did his PhD study here at Lincoln University on subterranean clover. But multiple cultivars of subterranean clover that come out of Australia. So early, the variation there is early flowering to later flowering, and how much of their resources they devote to seeding. So subterranean clover, balansa clover, gland clover, Persian clover.
What was that third one?
Gland clover.
Gland.
Yes. Flowers extremely early, like August.
Okay.
Oh, so sorry. So August, September, late winter, early spring it flowers.
The equivalent of crimson clover, about the same thing.
We don't have, yeah, okay. We things like sulla, crimson clover, sainfoin are not very common in New Zealand today. People have heard of them in the past, but you don't find them as much. So white clover most common, red clover. I'm talking about the trifoliums here. Lucerne or alfalfa has become much more high profile for dryland areas. Exploiting its biology of the deep taproot, and under a grazing management regime that is specific to the growth of that plant, you can get amazing results. And Professor Derek Moot here at Lincoln University has really championed that as a response to drought conditions or climate change, of having a lucerne alfalfa-based finishing system for sheep and beef cattle. So alfalfa, red clover, subclover, a whole host of annual clover species that we use to target. In fact, that leads into some other photos. Here we go. So where we exploit or use such annual clovers or more specific niche clovers is in the hill and high country. So this is a photograph taken near, it's in the central Otago or Marama area. So those of you who've been to New Zealand, sort of halfway between Queenstown and Christchurch. But what you've got there is in the low areas, a lucerne alfalfa based finishing crop or forage crop. And up in the hills can you see my cursor there, Woody?
Yeah, we can see it.
Everybody see it?
The alfalfa.
So we've got the alfalfa here, and then as we come up into the hills, you've got some improvement through aerial top dressing with lime or superphosphate, sulfur and phosphorus to feed subclover or naturalized annual clovers. Suckling cluster, hare's foot clover, there's a photo coming up shortly, and striated clover, which exists there naturally. They aren't native, but they came in through seed contaminant in white clover or in the guts of sheep 150 years ago, and they've established their own niche. But there are areas here on the hill country, on these faces, that we've targeted specifically, either a mixture of an early flowering and a later flowering subclover to give some flexibility to use the moisture when it arrives, and naturalized clovers responding to that too. A bit of balansa or gland clover used as well.
So in the same sward, you'll have multiple different clovers with different flowering periods.
Yes. In amongst, of course, the suite of perennial grasses and annual grasses, some of which are more weedy than desired. But you've got good ground cover there in general, but it changes with, as those annual plants die off, you get bare ground in the autumn, but that's prime sites for subclover seeds, particularly to germinate, but also other annual clover seeds. As we go higher, Woody, as you can see, the colour changes there. That colour change from green to tawny brown is a reflection of grazing intensity, where there's more animals and less, but also we're getting into more native real rangeland situations here. We've got tussock grasses or native power grasses, or our more hardy brown top Agrostis capillaris bent grass.
So
Sorry,
Go ahead.
quickly, a point I failed to make was how that landscape is used. So we've got ewes and lambs grazing here in the late winter, early spring, or in early spring for the lambs. But then as we get closer to the longest day, we will take animals off the hill country and closer to weaning, prioritize our high quality stock to put on weight on this improved lowlands with the alfalfa. So that's sort of a nutshell what's going on in improved dryland hill high country systems.
So just looking at that picture, the hillside, the one we just had there. Yeah, that one. Looking at that one, the lower parts of those hills have been improved. If they had not been improved, they would have been like the upper parts of those hills.
They would look more like the upper parts of the hill, yes. The other factor there is called subdivision, where there's a fence or not, the ability to control. Woody, you know about this very well, and others people listening too, the ability to control your pasture resource and your grazing pressure, and therefore regrowth and quality of the regrowth through fencing, which we call subdivision. So subdivision, strategic use of fertilizer to feed the legume component, and where possible adding new species that might fit a particular niche, say a summer dry, a sunny face, a hillside that's facing the equator. We're going to dry out earlier, so there's moisture there in late winter, early spring, so you've got a flush of growth, and you try and really exploit that before it dries out, versus around here where it'd be more facing Antarctica, which is a southern face for us. It's the other way around in the southern hemisphere. It would hold on to moisture, and there's more feeding value there in the summertime when it's dried out on the sunny face. So,
okay.
Yeah.
And a lot of that was
talking about some of these clover species. So this is hare's foot clover, Trifolium arvense. It's called hare's foot because the little seed head, like a hare or rabbit's foot. It looks quite small there, but it is like a carpet and naturally occurring. A dark green velvety leaf. Now what we're looking at there are some experimental plots that have had treatments of lime or phosphorus or sulfur, and in this particular case we've got balansa. But look at, if I zoom in, you can see there's the sown species, but we've got the resident species of sorrel, sheep sorrel here, hare's foot clover, some hardier grasses and so on. So it's
hare's foot clover.
Hare's foot clover, Trifolium arvense, or hare's foot trefoil. Now, I want to put this up because this might be controversial or interesting. Certainly controversial in New Zealand. Now, what you're looking at there is something you're probably more familiar with in the Pacific Northwest, lupins, Lupinus arboreus. Now, believe it or not, that particular plot, which I'm outlining with my cursor there, that is the native situation. That's the control. So we've sown lupin seeds, and they've done the best in essentially the most acidic soil. It's had no lime treatment there.
pH would be what, you think?
The pH there is not much far above 5, 4.9, 5, 5.1.
Right. Okay.
Right. So, and as you can, and so one of the interesting things that's come out of the high country research that my colleagues have done, this particularly Dr. Alistair Black, is that lupins do very well, extremely hardy, got a massive root mass that is resistant to soluble aluminium, which is toxic at acidic soil pH to most other plants. It's resistant. It provides some forage value, though it's high in condensed tannins. Sheep do eat it, but also shelter for lambs in this more high country, closer to an alpine environment. And it's a legume, so it's fixing nitrogen. Every every ton or 1,000 kilograms of biomass produced in a season is fixing 30 kilograms of nitrogen per hectare. That goes for any legume. That could be alfalfa, subterranean clover, white clover. That's the relationship. So that's how we get nitrogen inputs into country like this, where it doesn't warrant bringing in urea and flying it on or trucking it on. Let nature do it through the plants to then boost the grasses and so on.
The lupin, there's a lot of lupins in the United States and North America that are quite toxic. Those are ones that you're planted here it's a different type of lupin that is used. They come from Australia because there's lupins that are quite safe for animal grazing, and there's other species, mostly more in wilder areas that are very toxic. So obviously these aren't toxic, but where do you get them from?
It's a good question, Woody. So these are naturalized. The lupins you find growing on the roadside in New Zealand are naturalized cultivars. Some from North America, some from Eurasia as well. I'm not familiar if this particular lot has come from Australia. That we do have some hybridization, but there's the Russell lupin, and there's also blue lupins, and they can hybridize. But in terms of regards to the toxicity and high alkaloid levels, we haven't observed any issues with the sheep in the high country, mainly because they've got all these other things to choose from as well. Then, but yeah, now that's an interesting point.
Well, you don't have the toxic species. That's my issue is that there's a lot of different types of lupins out there, and there are a couple of different genera, and there are some ones that are well known as toxic, but there's others that are simply not toxic at all. They may be high in tannins, but that's it has other advantages.
These aren't toxic. The ones that we have in New Zealand, which are naturalized, exotic and naturalized, of course. We don't have any native ones.
Okay, we've got about 2 or 3 more minutes, Tom. So I had a question here about during the winter, how do people manage the pastures when they're grazing them and they have brassicas through the winter? Is there any special thing they do to manage those things?
So so if I understand the question correctly, how do you manage grazing on a winter brassica crop?
Well, how do you keep the soil health? Because you got a lot of animals, you got a lot of rain, and they're grazing brassicas through the winter. Is there any effects or any special management that's used to protect?
Right. Yes, you have to make allowance in your management for some damage to the soil surface, but following a strip provided to sheep or cattle of that given brassica crop or fodder beet crop, there's a sacrifice paddock that they can come back to where we'd feed some hay or silage, and also there's some standing saved pasture cover, perennial ryegrass base or whatever. So the animals aren't essentially allowed, following best management practice, aren't given free rein of the brassica crop to just do damage to the soil repeatedly over a 24-hour period.
So
we give
sorry? They routinely use a sacrifice pasture.
Yes. Or that with the location of that brassica crop, that winter feeding crop is right next to or part of pasture that's saved where we feed out hay or silage to manage the nutrition of those animals over the winter period. Also things like a back fence, so fencing off the area the animals have been the previous day so they're not going back onto that area that has already had some heavy foot traffic. So if there is, as is naturally the case, a rainfall event over the time that we're feeding these animals, from anything to 1.5 to 2 months over winter, or 2.5 months, that soil that has taken a little bit of a battering already is not getting it again. But in reality, I'm not going to lie to you and say that the soil health is pristine and preserved over that winter period, there is a little bit, there is damage that goes on, inevitable, particularly with a large animal, but we try and limit and reduce the severity of that through practices like back fencing, taking the animals off back to their home paddock, which is sort of their runoff paddock, which is pasture based, where we would feed out hay and silage as well.
Well, we are, well, this conversation is really fascinating, and we could probably go on for hours and hours. We have come to the end of this hour. Now, this is, we're getting, well, over on your end, Tom, it's, what is it there, 8 o'clock?
It's just coming up 8 o'clock, and yeah, it's light outside now.
Okay. Well, we're gonna, now you can do the rest of your day. And get yourself a cup of coffee or something, but or tea, however that is. But we'll end right now. But before we end, I'll let everyone know that these Oregon OFGC Forages e-forum are being done every week. They're free, of course, and everyone is welcome to join us. The next week, our John Marble, rancher from Crawfordsville, will be the host, and his guest is going to be Kathy Roth, who is from Arizona, is the publisher of the online magazine publication called On Pasture. And Kathy is an extremely interesting person. And the week after that, John will also host a man named Dallas Mount, who has taken over the ranching for profit courses that have been going for many years. So we're going to be doing this for at least a few more weeks, and we've got very interesting people coming on each week. And again, they're free, but you do have to register for each one separately. It's the nature of the Zoom system, and it protects everybody from being, you know, from the various security issues that Zoom could be liable for, and the registration makes a big difference. So you have to register for each one separately. It costs nothing, but you just have to do that each time. So we want to thank everybody we had some very good questions. We built them into a number of the conversations. And Tom, we certainly want to thank you. You've gotten up early to join us. We're really delighted that you were able to share a lot of this information and show some very interesting photographs. And those people who've never been to New Zealand got a chance to see things that they don't often see. A lot of that, a little bit, looks a lot like Western Oregon. So, you know, it's not like it's Mars. but we're really glad that you were able to join us and spend the time with us. Thanks again. And thank you everybody else for joining us for this period. Tom, we'll see you again. Hopefully
Thank you very much, Woody. Really enjoyed that, and you're a really good facilitator. Yeah, we could have talked more, but yeah, thank you for the hour, and hopefully those listening got something out of it. It's always good for me because we compare notes, as it were, with the Oregon experience, the New Zealand experience, and it's learning all round. So, but thank you.
All right. Well, we're going to ask our
message from Glenn Shoemaker. Thanks, love New Zealand. Is that Glenn Shoemaker from University of Idaho? I'll maybe send him a message.
About 30 people on, so it's been very good. Thank you, everybody. Connie, I think you can shut us off now. Connie Carr is our IT god for the day, and she's in charge of the entire, as you know, IT people know exactly what they're doing and are able to control the whole system. So thank you, everybody, for being on. And
yeah, thanks, Connie.
We're glad that you joined us. I don't know how to turn this thing off.
Yeah. Right, thanks everybody. Thank you for having me on.
Connie.